Okay, hi everybody. My name is Dan Kirshner. I'm the Executive Director of the Northwest Gas Association. Most of you know me, so I won't bore you with my bio since I'm your presenter today. And I'm looking forward to discussing with you our Pacific Northwest Gas Market Outlook, the 21-22 version, which takes us through 30-31 heating year. As is typical in these webinars, we ask you to keep yourselves muted for the webinar, and we'll ask you to enter your questions into the chat. I'm entering one now so you can see where it shows up on your screen. And I'll be monitoring that throughout my presentation today. So please, as you have questions, please enter them into the chat there. As I said, I'll be monitoring them and we'll do my best to answer them pretty quickly once you've posed a question. So we have about 25 or 30 people on the call. I'm glad to see you. We will make this presentation available after the webinar in PDF format. It's also being recorded and you can find it. You'll be able to find it probably by tomorrow, maybe late this afternoon, but let's plan on tomorrow on our YouTube channel. Can somebody, anybody, please give me a quick chat telling me that you can hear me just fine and you're seeing my screen share. Even a thumbs up. Okay, Judy, thank you, Judy, for letting me know. Appreciate it, everybody. Okay, so one last thing before I get started on the Outlook study. Our next webinar, we skip August, and our next webinar will be September 15th, Thursday, September 15th from noon to 1, featuring the CEOs of the Oregon Home Builders Association and the Building Industry Association of Washington, talking about how energy policy affects affordable housing. That should be a fascinating webinar, and we strongly encourage you all to participate, attend, ask questions, and learn more about that. So with that, let's get into the Northwest Gas Association Pacific Northwest Natural Gas Market Outlook. First of all, just a slide. I think most of you on the call are actually belong to or are employees of some of our members. These are members and a map of the 6 natural gas utilities and the 3 interstate natural gas pipelines that serve Oregon, Washington, Idaho, and British Columbia, and the pipelines that ship gas to and through our region from production areas in Alberta, British Columbia, and the U.S. Rocky Mountain West. So that's who we are as a gas association. I'm sorry if I sound a little rough. I've been on the verge of losing my voice for about the last 2 weeks, but hopefully we'll be able to make it through. So we just like to put a little ditty up that tells you how many folks our members serve. This is as of the end of 2020. You can see that collectively our members serve 3.3 million households. That's about 10 million people in Idaho, Oregon, Washington, and British Columbia. And they do soothe miles or 200,000 kilometers of installed, reliable, safe energy delivery infrastructure. We also serve, in addition to the warmth and comfort we serve to those 10 million residents of the region, we serve, the members here serve productive energy to more than 300,000 businesses, institutions, and industries across the region. So those businesses, institutions, and industries employ hundreds of thousands of people across our region. So natural gas is a key part of the region's energy infrastructure. Okay. Moving on, I just wanted to talk briefly, and this is in our Outlook study. I'll have a link at the end that will be live in the PDF document that we'll send out to you where you can go download the Outlook study itself. But we just want to make a point of saying some of the benefits of natural gas as a part of our energy mix in the region. And you can see that warmth and comfort for 10 million residents, efficient low-cost energy that fuels hundreds of thousands of jobs across the region. We make up, actually, when you include natural gas for generating electricity, more than half of the region's consumption of energy is supplied by natural gas. If you take, and I'll show this slide here in just a minute, if you take out the generation of electricity, it's about 45% of end-use energy on an average year is delivered by natural gas, about 55% by electricity. Our energy system delivers a low carbon fuel, and it's getting lower even as we're speaking today. We mentioned about 128,000 miles, 200,000 kilometers of energy delivery infrastructure. It really provides a fuel that is irreplaceable for some industrial processes. There are no alternatives to gaseous fuel. And it also is a good fuel for alternative fuel vehicles. So we'll talk a little bit about that too. And then finally, it makes up a very important part of our generation mix in the region, our electricity generation mix in the region as a reliable and dispatchable electricity resource. So just really quickly, what's the outlook? It's a unique, we take our member companies' IRPs, integrated resource plans, which are plans that they are required to develop that demonstrate what they are forecasting the needs are going to be and how they propose to meet those needs going forward, because they have an obligation to serve. So we take all of those IRPs in addition to the longer range planning data from our pipeline companies, and we aggregate that all together and we create a regional look at how we anticipate we're going to be using natural gas in the region for the next 10 years. We also talk a little bit about supplies, where we get our gas from, the price of natural gas according to some publicly available sources, demand growth, and our ability to meet that demand with the capacity we have available. So these are the things that we'll talk about today. All right, so regional supplies, we'll start there. This map shows you where we get our supplies of natural gas from. And as I mentioned, some of it comes from Alberta, some of it comes from British Columbia, and some of it down from the US Rocky Mountains west. I'll have a slide here that shows kind of a breakdown. About 60 to 65% of the gas that we consume here in the Northwest actually comes out of British Columbia. Probably another 10 to 15% comes from Alberta, and the remainder 20 to 25% or so comes out of the US Rocky Mountains west. Ultimately, if you're looking at the I-5 corridor, the vast majority of the actual molecules that you consume, even though the gas may be purchased in other supply basins, but by virtue of displacement, the actual molecules you're consuming really do mostly come out of British Columbia along the I-5 corridor. That's where we get our supplies from. I love this chart. This is a chart developed by Williams Northwest Pipeline, and it really shows how the kind of opportunities that consumers have in the region to source their gas from a variety of sources based on prices. And you can see here the lines across the chart are the price according to the basin. What is that? Blue, I guess, is domestic opal price. No, that's the dark one. So this is domestic opal prices in Wyoming. This is Alberta pricing at ACO NIT, and this is Sumas pricing. And so you can see how when Sumas pricing blows out a little bit, the amount of supplies that regional consumers are acquiring from that trading point declines. And the same is true as the opal trading hub had a price excursion there because of the Texas event. You can see that we used less gas from that region. Now, some of it's constrained, and this is again just Williams Northwest Pipeline. So this doesn't account for the gas that comes into the region from TC Energy's GTN pipeline. That's why I suggested that the percentages in the previous slide are a little bit different than what you see here. But even here, you can see 60 to 65% of the gas comes from Canada, and another 30% or so comes from the US Rockies. But it varies based on the cost of where that gas is. So there's a benefit to having optionality, being able to pick from each of these three different supply basins, to the extent that there's capacity available to ship that gas from each of these supply basins. I want to talk just a little bit about renewable natural gas. You all know what it is, so I'm not going to spend a lot of time on this slide, but it's a benefit to the region. It's a benefit to the environment. Frankly, it takes a waste stream and puts it to a beneficial use. If we did nothing with these landfill or wastewater treatment plant or even dairy digesters and the like, if we did nothing with it, it would just be methane that went into the air. In some cases, it's methane that's flared, not put to any good use. In the case of renewable natural gas, we're able to capture that biomethane and upgrade it to pipeline quality and actually put it to use. So while it's still combusted, it's combusted in a productive way rather than just simply combusted or allowed to escape into the atmosphere. Now, there have been a lot of discussions about how much is available, how much RNG is really available. And there's one study out there done by the American Gas Foundation that indicates that that renewable natural gas by 2040 could make up technically, potentially, I should say, could make up as much as 95% of residential consumption in the US. So there's a lot of gas available. And it's a little bit disingenuous when we hear from people that, well, we have to limit the renewable natural gas we get to the jurisdiction in which we're operating. In Oregon or Washington, we've seen various analyses that say today, using today's technologies and today's feedstocks, that might be 3 to 5%. But the fact of the matter is, across North America, we have more than 2.5 million miles of pipeline system that's all interconnected. And if you can chart a pathway from a production, from an RNG production facility in, let's say, Arkansas to Oregon, you can buy the environmental attributes of that renewable natural gas. So it is much more available to us than we are able to produce physically in our region. And that's how we really need to think about the renewable natural gas supply. And then another part of it, of course, this actually just shows, courtesy of the Renewable Natural Gas Coalition, which has been a good partner of ours, where facilities are currently operational. You can see there's 251 operational across North America, with a bunch more planned to be in operation by, I think, 2030 this is. So it's growing. I could tell you that from 3 years ago to today, it's night and day. The RNG development and production has just taken off, and they've got a bunch of good information on the RNG Coalition's website in their infographics that can show you the growth of production in volume and the like. I encourage you to look at that, rngcoalition.org. That's a good resource for you. And of course, hydrogen will be a part of the future. It's the promise today. We're looking at developments. I know Puget Sound Energy is working on them. Fortis BC and Enbridge is working on a study and a project. Northwest Natural is working with Eugene Water and Electric on pilot projects for hydrogen, trying to get a clear understanding of how much we can bring in and what tweaks to the transportation distribution system are required to bring it in. But hydrogen's real. It can be green, as this chart shows, by using surplus renewable electricity to power electrolysis, create renewable hydrogen, and then it is now storable as a gaseous fuel. You can store it for long range and draw on it when you need it. So this is an important part of the future of decarbonizing our fuel, the fuel that that 200,000 kilometers of pipeline delivers to the 10 million residents and 350,000 or so businesses, industries, and institutions across the region. Let's take a look at prices. This is the historic Henry Hub price. So I think most of you are probably aware of what the Henry Hub is, so I won't go into it, but it's a trading hub in Louisiana that serves more or less as a benchmark for North American prices. And you can see here that today, even with the recent price excursions that we've been experiencing here since the Russia-Ukraine conflict, you can see that we are on a decadal basis lower than we have been ever, really, since we've been tracking these prices since 1981. So the decadal average here in the 2010 and teens is $3.37 a decatherm. So in 2021 dollars. So we saw some price excursions there. This is Hurricanes Rita and Katrina. Around this period of time, this was Hurricane Andrew, both of which took out some significant supplies in the Gulf of Mexico. But since then, I would say at this point in time, about 20% of North America's natural gas came out of the Gulf of Mexico. With the advent of horizontal directional drilling and hydraulic fracturing, that percentage has dropped to about 5%, and most of the natural gas now in North America is produced onshore, which means, among other things, that it's less susceptible to those kinds of disruptions that we saw during this period of time. And I'll go to this next slide here. This is the forecast price. That dashed line there is what the actual, what the short-term energy outlook price forecast is by EIA. So they do a 2-year outlook. You can see it's a little higher than their longer range outlook. The annual energy outlook 2022 is that solid blue line. You can see that they are forecasting that prices will be higher in the near term, but declining over time back to a more reasonable and fairly level growth. We'll have to wait and see how that all goes. I could tell you that the jagged lines that you see there, those are the Northwest Power Conservation Council's most recent update of their fuel price forecast at the trading hubs that we pay closest attention to: Opal in Wyoming, Sumas at the Washington, British Columbia border, and ACO up in Alberta. You can see that ACO typically trades at a discount to the Henry Hub and to the other basins. So again, I'll be curious to see what the 2022 outlook looks like when we factored in some of the geopolitical stuff that we're seeing today. And there's many of you on the call that know much more about the fundamentals behind what's going on with the current price excursions that we see here than I do. So we'll leave it at that. Let me just stop here and see if there are any questions. I'll give you 5 seconds or so to start typing things in. I'll move on, but I'll come back to the comment and look in the comment box to see if you've entered any questions, and we can go back to slides if you need. Okay, let's move on a bit. This is continuing the price forecast side of things. This is actually delivered fuel price forecast, the all-in forecast by the EIA for basically transportation fuels. And you can see that natural gas is forecast to be at a significantly lower. This is delivered to the pump, from a wellhead to the pump, per gasoline gallon equivalent. And you can see gasoline is that kind of greenish brownish line, and diesel is that top blue line there. So natural gas as a transportation fuel is cheaper, certainly cheaper, but there's also refueling issues. It's hard to find places to refuel. So moving on to the next slide, the focus on the transportation sector is really on medium and heavy duty transportation. Personal transportation, that's a perfect market for personal transportation and some medium duty transportation. And we think that's probably where it makes the most sense, is for EVs. But in the heavy duty sector, when you talk about loading on the weight of batteries, extra weight for the motive technologies means there's less payload, so less load that you actually get paid to deliver. Today, there really aren't. There's lots of research around it, lots of development occurring, but there are no applications today that are commercially viable, in especially the heavy duty market, for electric vehicles. As I say, lots of development going on, good things happening, but today you can buy a natural gas fueled heavy duty vehicle that meets the grams, the NOx and SOx thresholds of EPA. You can see here that dashed orange line down there says that at any speed, a natural gas engine produces this amount of NOx, and that's at any speed. So it doesn't change. Whereas with a diesel engine, the clean diesel engine in particular, that's that sloping line. When you're going slower, you're emitting much more NOx. And up until you get faster, 40 miles an hour plus is where you finally start meeting the EPA standard of 0.2 grams per brake horsepower. And so they're clean engines. They do cost a premium, and there's a little extra weight to them, but they're a technology available today, and I am aware, and I think many of you are as well, that Cummins is coming out with a 15-liter engine. So they typically go in 6, 9, 12, and 15 liters. 15 liters are the biggest Class 8 engines. They haul 110,000 pounds of freight, and they can do it up and down mountains and the like, and that's been the piece that's been missing. But Cummins is about to release a 15-liter engine here within the next year, I believe, maybe even less than a year. It's out there and they're marketing it already. So good application for a natural gas alternative fuel vehicle. Before I get into this slide, any questions so far? Again, I'll take just a minute to give you a beat, and I'll take a drink of water while you enter questions into the chat if you have any. Okay, well, seeing no questions, and please feel free to enter them in. I'm monitoring it real time, so I'll get to them when a question is entered. Let's look at how we have used natural gas in the region. There's a couple things that are notable in this slide. One is you'll see that the industrial demand, that's the maroon segment of these bars, has kind of declined over time, really. That really happened in two tranches, one on the heels of the Western energy crisis in 2001, 2002. That was the primary metals market exiting the region. The aluminum smelters, I think at one time we had 8 or 10 smelters that employed more than 10,000 people. And today I think there's one that's still operating at partial capacity, maybe 2. So industrial demand has declined slightly over time. The other thing you'll notice in this slide is generation has, if we put a trend line on that top yellow piece, you'd see that generally generation has increased over time. The gas we use to generate electricity has increased over time, but it's also quite variable. Natural gas is the fuel, the generation fuel on the margin. So it's the last fuel on when when hydro and nuclear and wind and solar and even coal, to the extent that we're still burning any, are maxed out, then we still need more, that's when gas comes on. It's also the first one off. So when we have enough of all those other resources, gas is the one that's shut down. So as you see there, we take a couple slides here, take a look at that 2011 bar. You see, we didn't generate much electricity. Some of you may recall, as I do, 10 years ago when we had a whole bunch of wind in the region and a whole bunch of water in the region. And actually, I think I recall BPA had to curtail wind on its system because they just couldn't take it. I think there was even litigation over that. I don't recall exactly, but the point is that we didn't need much gas, so we didn't burn much gas. Now, fast forward to 2019, where we burned more gas than ever before. I don't remember if that was a particularly dry year, what was going on there, but it was a cool winter. I do remember that. And you can see that's what happens. So gas fills the gap for electric generation. I have a question here. Let me take just a minute to read it. So question from is I was speaking earlier about out-of-state RNG and chain of custody to acquire the environmental attributes of RNG. Is this a concern being raised by governments in the Pacific Northwest? What have I heard? I wouldn't say it's a concern. I would say what I've seen, Jennifer, is there is this sort of sense that the only RNG we can consume is what's produced within our own jurisdictional boundaries. I don't know that that comes as much from government as it does from advocates for one or another issues. I think what I'm just trying to say is we need to be aware that we can acquire those attributes as long as you can demonstrate a pathway to its consumption from pretty much anywhere in North America. Thank you for the question. The other thing I'll note on this demand slide is the residential commercial demand varies. Those are very weather dependent demands. Industrial demand is typically not. Electricity demand for fuel to generate electricity is in a different way. But you can see kind of that bottom piece there, the residential demand for electricity varies as the weather, typically for us, it's as the winters are colder or warmer. That's when you see more gas or less gas in residential demand. The last thing I'll just note for you is that orange line across the top is how much electricity the region consumes. This is based on kilowatt sales in each of our jurisdictions. So this is end use electricity. And what that compares to are the first three segments of the columns. So about a little less than 55% of end use, excluding transportation energy, a little less than 55% of end use energy is electricity. A little more than 45% is natural gas. And when you add in the fact that natural gas generates a good chunk of that electricity, it just brings the point home of how important a resource our natural gas is in the region and especially the infrastructure that delivers it to and through our region. And just to make the point, this is a one period of time. We often talk about how much energy does the system deliver. I could tell you on a cold day in different parts of our region, it could be on a cold day, 90% of the energy being consumed could be being supplied by natural gas in different parts of our region, as I said. This is just one example of a particular day, a peak hour, which is almost always 7 a.m. to 8 a.m. When people are getting up, taking their showers, turning lights on, getting the house warm, etc. January 5th, 2017, from 7 to 8 a.m., you can see that the region consumed about 30 gigawatt hours via the electric system and about almost 45 gigawatt hours via the gas system or 1.5 times as much as was delivered by the electric system during that 1 hour. That 44 gigawatts is equal to about 6.5 Grand Coulee dams. So just imagine on that 1 hour how much energy is being delivered by the really terrific, by that 200,000 kilometers of natural gas delivery infrastructure that we have in the region. I want to take a look and kind of compare for you all what's been happening. We've been doing the Outlook study for, I think we've done at least 15 iterations of it. Our first one we did was in 2004 or 5. We've had a couple of years where we spread it out a little bit further. This last year was one example. But so for the last 10 years, this is what the forecast looks like. And if you see 2016 is that bottom bar, the blue, and then the darker orange is 2017, and then the gray is 2018, 2019 is the yellow, and guess what? Here in 2021, that dashed blue line. So we saw increases, generally speaking. 2018 and 2019 were pretty close to the same, but now we've seen a decrease for the first time over previous forecasts. So we find that really interesting, something to chew on perhaps, and there's more detail which we'll get into. And so if you take a look at our 2022 outlook forecast, last year we were at 1% compound annual growth rate. It was about 1% for residential, which is the green line here, about 1% for commercial, which is the red line down at the bottom. It was about 1.9% for generation increase, and about 0.2% for industrial. Well, you can see that the numbers really haven't changed much for residential, commercial, and industrial demand. But for the first time since we've been doing the Outlook study, we are seeing an actual forecast decline in demand for natural gas as a generation fuel. This is really interesting, and I think reflects the policy environment that we're in. I do have a question here. Again, are these numbers normalized for weather? If you go back to this chart, no, this is actual weather. These are normalized. So this assumes normal weather. And of course, we do have an appendix in our Outlook study that describes how different utilities across the region develop their forecasts, the assumptions they make, including weather assumptions, how they're incorporating, whether they're incorporating, and if so, how incorporating climate change into their models, et cetera. So thanks for the question. So again, first time we've seen in all the years we've been doing the Outlook study, first time we've seen a decline, a forecast decline in gas for generation, reflecting a new policy environment, really. These IRPs came in after Washington State passed its Clean Energy Transformation Act, which aspires to having carbon-free electricity by, I think, 2045. I could have the number wrong, but I think that's what we're starting to see here is the policy environment affecting that. But there hasn't been much change, as I said previously, in the residential, commercial growth and industrial growth. It's just kind of poking along there. Here's the power generation forecast I mentioned. So you can see every year we've been forecasting different years, different levels of growth. This is kind of a messy slide, but you can work it out for yourself there. This top one here is 2011. Every year, it might have gone down a little bit from one year to the next, but every year we forecast a increase in gas demand for generation until this year, when we see for the first time, as I said, a decrease in a forecast decrease in gas demand for generation. And this is our peak day. Again, the peak day's been pretty consistent for the last several years. This is 5 years, I think. I didn't put 10 up here, even though I have 10-year peak day forecasts. That's the last 5 or so forecasts. You can see they're all kind of bunched pretty closely together until this year. And we've seen decline. Some of that has to do with our member companies reformulating how they calculate a peak day. One time when I first came to this industry 20 years ago, many of the peak days were just predicated on the coldest day on record. And those, I would say those peak days, every one of our member companies has gone through a process where they've revised how they think about that. That coldest day may still be part of the equation, but it's not the peak day any longer. It's part of an equation instead. And we've gone to, I think, more probabilistic sorts of approaches in designing peak day. And that's part of, I think, what's going on here. It certainly doesn't describe all of it. But that's what we're seeing here. I think this is a very interesting slide. I did want to take just a minute to talk briefly about methane emissions. It's a big, it's an issue that's often discussed. And I just want to point out that in the US, methane emissions per 1,000 cubic feet of gas produced has been declining and continues to decline since 1990. We have new initiatives underway that have really taken off over the last couple of years from things like responsibly sourced gas, which measures things like methane emissions from production, to big programs by major producers and others to capture the methane. I think everybody understands methane is the product that they sell, and letting it out of the pipeline is that much less that you can monetize. So much less, and then of course it's very important from an environmental perspective as well. But there are motives to get us down, and I think we're seeing it down pretty significantly since 1990, and it's continuing, and I think will only accelerate. I think of one program called One Future, where several of our members are members of this entity called One Future. The aspirational goal of One Future is that every member of One Future, that collectively their methane emissions amount to less than 1% of, hence the phrase One Future. Currently, all the members of One Future are really significantly below that goal. So that's a good thing. Just another point to say this trend will continue. We see, of course, from producers to midstream pipelines to the distribution companies, plans for decarbonization, plans to tighten the systems where tightening can occur and to capture this methane. So just another point on emissions. This is carbon emissions. I've got the headline up there says methane emissions, but this is really carbon emissions for Oregon, Washington, and British Columbia. Idaho doesn't do an emissions inventory, so I couldn't include them in here. But you can see that residential combustion of natural gas, residential and commercial combustion of natural gas in this region makes up 8% of the total carbon emissions from that region. Other residential commercial fuels that create carbon emissions is another 6% on top of it. Industrial natural gas is about 5% of the carbon emission budget, and then other industrials another 8%. But always, and everybody knows this, always transportation is the big, the 800-pound elephant in the room. So that's the one. I thought this was an interesting slide. It's included in our outlook study. It's important to put these things in context, I believe. Let's talk a little bit about infrastructure. This is a nice chart that shows capacities at different points and with different facilities. So if you're interested, when you get the PDF, you'll have this. It's a nice little chart, and hopefully you'll find it useful. But this describes the pipelines from TC Energy's ACO system, NIT system, and Foothills to its GTN system that comes on down to California and helps supply Medford as well, Southern Oregon, to Enbridge, T-North, T-South system, Fortis BC's Southern Crossing, and then of course Williams Northwest Pipeline That is what all of our members have in common in one way or another. That's and then there are the storage facilities. So you see a couple of LNG facilities here, and underground storage as well, with Mist here and Jackson Prairie here. Okay, it's a pretty good system. And this chart just demonstrates the capacity of storage in the region. Maximum withdrawal rate, for underground storage, we can deliver a lot of gas using our underground storage facilities over a fairly extended period of time. The peak shaving facilities, those are the liquefied natural gas facilities throughout the region. We can deliver, again, to meet that needle peak for several days, in some cases a few days, but you can see this is together with the pipeline capacity, which is almost 4.2 BCF a day. We've got almost 7 BCF a day of capacity to serve load in the region. And this is a chart that shows how we meet demand. And so what we have here are the peak day, which are the tallest columns, an average winter day, and that's January is our coldest winter month. And then our average, what I'll call shoulder month, it's the lowest demand. It's May for the first 5 months, and then that actually moves to June for the second 5 months, but it's all about the same. And you can see here that we have typically a little more than 4 BCF a day of million decatherms a day of capacity, of pipeline capacity. And that pretty much is enough to serve an average winter day. And then you get up into, then you've got to get up into, when you get a colder than average winter day, you've got to get into that underground storage. And when you get up into those needle peak days and these peak days, then we're using those LNG facilities. So a couple things to note about this slide. One is this assumes that all of the peak days, design days that we've talked about, where our member companies have created this design day for planning purposes. This aggregates them all, so it kind of assumes they're all occurring in Vancouver and Boise and Spokane and Portland, all at the same time. Now, that's not unheard of. Cold snaps have occurred coincidentally across the region, and that can stress the system. But usually they roll across the region rather than occur coincidentally. So it does happen rarely that we get these coincidental very cold days. We haven't hit a peak day. I don't think any one of our member companies has actually hit an actual design day, but we've come pretty close in an aggregate of using up the system. So this slide would tell you that the system is right-sized. It's not overbuilt. We haven't spent more money on infrastructure than we need to ensure, but it also tells you, so if you're a regulator, I like to say, if I'm a regulator, I'm looking at this picture saying, yeah, that looks about right to me. But if I'm an operator of the system, I'm saying, yikes, the margins are pretty slim here, and I'm feeling a little nervous about it. So that's what this slide shows. And then this last slide here, I think this is my last slide of my presentation. This just shows the transport load factor. So what the pipes are able to deliver and how much they actually have delivered. So from left to right, each of the columns is 2016, 17 through 2021, 2020, 2021 by month. So each of the columns is, 2016, 17, 2017, 18 in November, right? So each by month. And you see for the 3 coldest months of the year, the average utilization factor of the pipeline system is at 95%. That's right. I mean, we're using everything that we have is another way of saying that. And that's really important for the region to think about. as we contemplate some additional growth. It's not going to be super fast right now. We saw from our demand forecast, it's fairly modest. But if other projects, major projects come online, this will have implications for the region and things that we need to contemplate, because it does take time. If additional infrastructure is necessary, it takes time to build it. We don't want to find ourselves as a region needing infrastructure today or 3 years from now, and having that infrastructure be 5 years away. So I think it's very important from a planning perspective that our region thinks about that. And I can tell you that every one of our members does think about that quite frequently, and are always planning for those purposes. So that is my last slide. We're wrapping up about right on time. I'm going to take a minute here just to give you a minute to ask any questions that you may have. Please enter them into the chat. You can see here this link will take you, and it'll be in the PDF. It'll be live in the PDF that if you send Judy or me a note asking for our presentation, we'll send you this PDF file. But you can download it directly, the Outlook study itself, which is a beautiful document, by the way, by going to this link. This page you can actually download the whole study if you want, or you can download chapters of it if you want, including each of the appendices. So, and I mentioned to you that there is an appendix in here, I believe it's Appendix C, that shows how different companies, the assumptions that go into their modeling, including how they create a design day. So hopefully you'll find that useful. Okay, any other questions before we're wrapping up? We're just a couple minutes early. Good. Oh, here I've got a question here. Will Washington's Climate Commitment Act, that's the Cap and Trade Act in Washington State, be more of a factor in the next study as CETA was for this study? I would say my guess is yes. I think another thing that's likely to come into the next study is Oregon's Climate Protection Plan, which is a cap, not a cap and trade program, but a cap program. I didn't spend a lot of time on new technologies, but I was just here meeting with a great technology that's going to help not only residential customers, but also commercial industrial customers decarbonize using the gas system, which will create opportunities for credits under both of those programs, hopefully, and continue to make use of the gas system as we move into a zero carbon future. But I'll say, in answer to the question, again, the short answer is yes. The Climate Commitment Act in Washington State and the Climate Protection Plan in Oregon we're likely to see those policies reflected in our next iteration of the Outlook study. I think we're also likely to see other projects that you didn't see in here. For instance, wood fiber LNG is a big project up in British Columbia that has, I don't know if it's actually gone to FID, but it does have a notice. They are proceeding with construction. They have, I think they've devoted the first $600 million to it or something like that. So we can expect that project to come online. Those decisions weren't made by the time we got this data in, and so we weren't able to incorporate it fully. We do reference wood fiber LNG in there. So I think that's another thing that we're likely to see is other developments coming forward. Any other questions? I'll give it just 10 seconds or so for folks to write other questions. Yes, the slide deck will